Now, good morning, everyone. We are going to start with the last paragraph in this chapter, which is about oxidation of alkenes in the presence of potassium permanganate solution. Now, oxidation of alkenes, it means that first of all, the double bond will be removed. First of all, the double bond will be removed. Once we remove the double bond in the presence of heat and in the presence of potassium permanganate, and in an acid medium. Now, once we remove the double bond, each carbon atom will be bonded to a hydroxyl group. It means that a diol will be formed. Diol, it means a dialcohol will be formed. So this reaction, in fact, it is an oxidation reaction. This reaction is an oxidation reaction. Now, I repeat, alkenes can be oxidized in the presence of potassium permanganate solution, and the solution must be a diluted solution. And the solution must be a diluted solution. Now, diluted solution, it means that it has a low concentration. Potassium permanganate is of low concentration and must be acidified. Must be acidified. Now, acidified in the presence of an acid. And the acid here is H2SO4. Now, H2SO4 is used as an oxidizing agent. It is used as oxidizing agent. Oxidation of alkene will take place in the presence of potassium permanganate and an acid solution, which is sulfuric acid H2SO4. Now, first of all, the permanganate solution has a purple color. Now, purple color directly will be converted into colorless due to the formation of Mn2+. And the alkene or alkenes are oxidized into dialcohol. Why oxidized into dialcohol? Are oxidized into dialcohol because once we have removal of the double bond, each carbon atom now will be bonded to a hydroxyl group, so we get a dialcohol. So if we have only one alcohol, one hydroxyl group, so we have a monoalcohol. So since it is a oxidation reduction reaction, it means that we have two oxidation reduction reactions or two half reactions. Two half reactions are the reduction reaction where MnO4- is reduced into Mn2+. Now, in order to balance this equation, first of all, we balance the element which is not oxygen, Mn. Here you have one Mn, and here we have only one Mn. Now, after balance, so Mn is balanced. Now, Mn is balanced. Now, MnO4 is composed of Mn and oxygen. First of all, we balance Mn, which is not oxygen element. Then we balance oxygen by adding 4H2O in order to balance the oxygen. Once we add 4H2O, it means that you are adding 8 hydrogen, and hydrogen is balanced by adding 8H+. by adding 8H plus. After adding 8H plus, now we have to balance the charge. The charge is balanced by adding electrons. Here you have -1 or +8, it will be +7. +7, +2, so we add 5 electrons. So 5 electrons will be added in order to balance the equation. In order to balance the equation. Now this is the reduction reaction. Now oxidation reaction, where the alkene is converted into a dialcohol. When alkene is converted into a dialcohol, no change in the number of carbon atoms. Yani we still have the same number of carbon atoms. When R prime does not change. R with R prime can be alkyl groups and can be hydrogen atoms. Now, first of all, no change in the number of carbon atoms. So we have still have the same number of carbon atoms on both sides. But in the dialcohol form, so here we have one oxygen, and here we have one oxygen. So now we have two oxygen atoms. Two oxygen atoms are balanced by adding 2H2O. Now, when we add 2H2O, now oxygen will be balanced. After adding 2H2O, we have to balance the hydrogen. 2 times 2, 4, and 2, 6. So here we have 1, 2, 3, 4. So we add 2H plus, and directly we add 2 electrons in order to balance the charge. Now, after balancing the charge and the oxygen atoms and the hydrogen atom, now we have the reduction half reaction is balanced and the oxidation reaction is balanced. So now we add the two equations. So we multiply up by 2 and down by 5. Here we have 5 electrons and here we have 2 electrons. So we multiply the two with the first equation by 2 and the second equation by 5. So we get the overall equation. Yellow with 5 alkene plus 2MnO4 plus 6H plus. And هون في عندك 16H plus. And here we have 10. So H plus will be in the reactants. Now, then we add H2O, 4H2O, 8H2O here, and here we have 10H2O, 2H2O will be left in the reactant. Now 5-diol. Now 5-diol, it will be RCH. This compound, you have to replace it by the word diol, plus 2Mn2 plus. So here we get the balanced equation. So I will repeat. Now, oxidation of an alkenes with dilute potassium permanganate solution, permanganate يعني KMnO4 potassium permanganate. Potassium permanganate has a purple color. Now we add to it a few milliliters of H2SO4 in order to have acidified potassium permanganate. And here H2SO4, it acts as an oxidizing agent. And in the presence of heat, heat is added in order to remove, as we said last time, in order to remove the double bond. Once the color of the permanganate solution is converted from purple into colorless, it means that MnO4 minus is reduced into Mn2 plus, and the alkene is oxidized into dialcohol. And the alkene is oxidized into dialcohol. So here we have an oxidation reduction reaction. This oxidation reduction reaction is composed of two half reactions. The oxidation reduction half reaction, MnO4 minus, it gives Mn2 plus. So first we balance the element which is not oxygen, and here Mn. Then we balance oxygen by adding 4H2O in the products. Once we add 4H2O, so we have 8H plus. Now, Mn is balanced, oxygen is balanced, and hydrogen is balanced. So now we can balance the charge by adding electrons. -1 plus 7 plus 8, it will be plus 7. Plus 2, so 5 electrons. With oxidation reaction, the alkene is converted into dialcohol. As we said, no change in the number of carbon atoms. Directly we move to balance the oxygen. Here we have 2 oxygen atoms, so we add 2H2O to balance the oxygen. Then we balance hydrogen by adding H plus. 2 times 2, 4. And here we have 2, 6. 2 and 4. 2 and 2, 4. Then we add 2H plus. So here we have 2 electrons. So multiply by 2 and down by 5. Then we add the overall reaction. This is an example. CH2 double bond CH2, it is ethene. Ethene is converted into this dialcohol. Now, what is the name of this dialcohol? Now, first of all, you have to select the longest continuous carbon chain. This is the longest continuous carbon chain. So in carbon 1, we have OH. On carbon 2, we have OH. So it will be 1, 2, ethane. Now, double bond is removed. It will be converted from ethene into ethane, from alkene into alkane. Ethane, diol. Why diol? Then we have 2 hydroxyl group, so it is a dialcohol. But if we have only 1 hydroxyl group, so directly the name will be ethanol. But here we have 2 hydroxyl groups, so it will be converted into dialcohol, 1,2-ethane diol. On carbon 1, we have OH. On carbon 2, we have also OH. So the name will be 1,2-ethane diol. يعني ال OH, the hydroxyl group, we cannot put them on 1 carbon atom. So we remove the double bond. Directly, each carbon atom will receive OH. So it becomes a dialcohol. So it will be 1,2-ethane diol. Now, with this paragraph, oxidation of alkenes with dilute potassium permanganate. So we finished the chapter about alkenes. You have a homework for next time. You have a duration time till June 8th in order to deliver the homework. It is about alkenes. This is all for today. Have a good day and stay safe. See you next time. Do you have any question? Onitao, do you have any question? So see you next time.